Good morning, everybody. Welcome back to our Azure Database for MySQL monthly live webinar. My name is Jim Toland. I'm a Senior Program Manager with the Azure Data team at Microsoft. We're live today on YouTube, LinkedIn, Twitch, and for those who might have missed any of our previous episodes, you can check out our session recordings on our YouTube channel at Azure DB MySQL. Today's session, we have three deep dive topics, and then we'll take a quick look at our upcoming feature roadmap. We're going to start by learning about the general availability release of flexible maintenance features from Elendil Zheng, a senior product manager at Microsoft. And then next, we'll take a look at deploying MySQL Flexible Server using ARM, Bicep, and Terraform templates. And we've got Ram, a principal software engineer from Microsoft, to speak to us about that. And then finally, we're going to reiterate and share a little bit more information about the single server retirement date, which is quickly approaching. And we'll have Shreya Atal, a product manager for Microsoft. And then finally, I'll wrap up things with the latest features and upcoming roadmap. So, folks, if you have any questions or feedback during the webinar, or if you just want to drop us a hi and let us know about the topics you'd like to have covered in future episodes, please just drop a note in the live chat window and we'll take a look at those as we go, try to address them during the session. And as usual, our product expert, Sadish, is online to monitor the chat window to help answer any questions about the product that we don't get to during the session. Now let's get started. First, I'd like to welcome back Elendil Zheng, a senior product manager at Microsoft. Today, he'll share details about the GA release of flexible maintenance features for Azure Database for MySQL Flexible Server. Hi, Elendil. Thank you for joining us again today. Could you briefly introduce yourself before we jump into your presentation?
Okay. Thank you, Jim. Hi, everyone. I am the senior product manager at Microsoft, working at the Azure Database for MySQL Flexible Server. So today I'm going to introduce the latest GA feature, flexible maintenance. So yeah, let's go to the next page.
Over to you, Elendil.
Okay, sure. This feature has been actually in public preview for quite almost 1 year. So during this 1 year, we resolved a lot of technical issues we met for this feature. And also we learned there is a lot of customer feedback in terms of, they would like to have a wider range of reschedule window, and they would like to have the CLI support so that they can, reschedule their hundreds of servers during the maintenance period. So in the GA phase of this feature, we added these two features. So right now, our customers can reschedule their maintenance in a maximum 30 days reschedule windows, as long as there is no hard security compliance requirement. And we also provide a very strong power of CLIs for our customers to use during the maintenance period of time, so that you can write your own script to monitor the maintenance or bench reschedule your servers to meet your business requirement. Okay. Yeah, next, I'm going to share a demo of how the flexible maintenance feature GA version worked, especially in the for the CLI part. Okay, first let's take a look at our demo environment. I have three servers in my subscription on the Elendil CLI resource group. So these three servers now received a maintenance request. So while we are in the public preview stage, we need to go through the portal and click goes into this server, each server's overview page, then go to the maintenance blade. Click the reschedule button. Now, I think September the 22nd does not meet my business requirement, so I change it to the 26th of September. Okay, let's wait for a couple seconds to for this operation to be completed. Okay, cool. Right now we rescheduled CLI server 1 to September 26th. Now I need to log into go to the second server and do the same thing again. Okay, as you know that managing 3 servers is one thing, but if imagine you have like 300 servers, that would be your nightmare to go to the portal, click the reschedule buttons one by one, 300 times. So strong feedback we heard from customers that they would like to have the CLI support. So I'm going to share that how to use the CLIs to reschedule your servers maintenance time. So let's open Visual Studio Code window and open a PowerShell terminal. Okay, now let's first take a look at how the maintenance CLI looks like. So this CLI has 3 commands, so list, reschedule, and show. So using these commands, you can find out the current maintenance details of your server and execute the reschedule operations in CLIs. So let's take a look at how we can retrieve the reschedule detailed information using the reschedule list operation. So first, let's take a look at how the list command looks like. Okay, now you can see here is the maintenance details for my server reschedule CLI1 under the Elendil CLI resource group. Then I'm going to execute the reschedule command to reschedule this server's maintenance to my desired time. So I need to copy the maintenance, copy the name property from the previous output of maintenance list command. Then I need to type in a start time for the reschedule to execute. So the start time should follow the ISO, ISO time format. Let's try to reschedule it to the September 31, which is obviously not a valid date time. Let's see what will happen. So this command will take a time zone based date time format. So if you do not specify your time zone information in the start time command, you will see you will be rescheduled based on UTC time zone. So as you can see here, the September 31 is not a valid time. So it will tell you to type in a valid time. Now I'm trying to reschedule it to the September 13. Because this maintenance only allows you to reschedule your maintenance from the September 11 to September 29, which is our demo maintenance. So it will tell you that it's out of the maintenance reschedule windows. So let's try to select another start time. Okay, now we are all good. The reschedule maintenance, the maintenance has been rescheduled to September 28. So this is the basic usage of maintenance reschedule CLIs. Next, I'd like to share you that how to use the maintenance reschedule CLIs to write a script to bench schedule your server, your Azure MySQL instance under the same subscription or under the same resource group. This script is also available in our Azure MySQL blog. So you can log into the Azure MySQL blog, check the GA announcement blog for the flexible maintenance features, then download that script and run it on your side. Because this script is written written using a shell script, so we switch to a batch shell in Visual Studio Code. And let's take a quick look at the how the script looks like. So this script includes some parameters. You need to give the command your subscription ID, your resource group name, and the desired maintenance start time, and the maintenance name for this reschedule. And by the way, the maintenance name is actually the maintenance notification tracking IDs, which you can also find in your application, your server's maintenance plate. And this ID is identical in the under the same region. So as you can see here, I'm trying to run this script to reschedule all my server in the Elendil CLI resource group to September 2022. Okay, now all these three servers has been rescheduled to the same date, September 2022. So with the CLI support, you can not only bench reschedule your maintenance, but you can also write your own script to monitor the maintenance status, or write a bench script to view the maintenance status under the same subscriptions or same resource group if you have like hundreds of servers you need to monitor. So that is all for the GA version of flexible maintenance and its powerful CLI support. Back to you, Zheng.
Hey, thank you so much, Elendil. Really appreciate it. Folks, you can learn more about this functionality in Elendil's blog post at aka.ms MySQL-flexible-maintenance. Thanks again, Elendil, especially because it's so late in the evening, for sharing this detail with us, and really appreciate it.
Yeah, thank you, Jim.
You bet. Okay. Next, we're going to turn to deploying MySQL Flexible Server using ARM, Bicep, and Terraform templates. There's several options available, and I'm going to invite on Ram, a principal software engineer at Microsoft, to talk about these options for deploying Flexible Server. Here we go. Welcome, Ram.
Hey, Jim.
Thank you for joining us today. Can you tell us a little bit about yourself before we get started here?
Hello, everyone. My name is Ram. I'm a software engineer here at Microsoft working on Azure Database for MySQL Flexible Server. Happy to showcase some demos today. Yeah.
Fantastic. Thank you, Ram. Now we'll turn it over to you for your deep dive and demo.
Yeah, thank you, Jim. So today I want to showcase like how to deploy like a MySQL Flexible Server using ARM templates, Bicep templates, and Terraform templates. When you hear about ARM, Bicep, and Terraform, right, all of these things come under the category of infrastructure as code. What it means is it's a practice in which all your infrastructure provisioning and management, right, are automated through code, all right, rather than people manually going to portal and clicking through some things, or doing some other tools, clicking through some things. So everything is just written as code, all right, in JSON files or Terraform templates, and all these things. And this code is maintained in some source control like GitHub or some other form, all right. So this practice of having everything in code for infrastructure provisioning and management, this practice is called infrastructure as code. And there are like two approaches to it, declarative versus imperative. Declarative means like it defines exactly what is the infrastructure that is going to be provisioned. And imperative is like how to achieve the desired state. And under declarative, we have this three: ARM, Bicep, and Terraform comes under declarative approach. And some of the advantages of this using these templates and using IAC is like version control, right? All of this code can be checked in, and you can look at the version history, and you can have rollback capabilities and ensure traceability of all of these things. The other advantage is consistency and repeatability. So when you have it as code, right, it's very declarative, and only what is in code happens, right? There's no human error or discrepancy involved when you have everything as a code checked in. It just deploys whatever is there in the code. So you have consistable and repeatable environments, and you can minimize the human errors. And the last advantage of this is automation. Obviously, when you have everything as code, right, you can deploy, you can write automations using GitHub Actions, Jenkins. There are several tools that are available which can automate the deployment of this code, manage the scaling, manage all the infrastructure, have like efficient cost, and reduce like manual intervention from humans. So these are all the advantages of infrastructure as code. Next slide. So there are several popular IAC tools, and today we'll be particularly looking at ARM templates, Bicep, and Terraform. Just give a brief intro about these three. ARM templates are JSON-based declarative templates. This is very particular to Azure resources, and you define the template in a JSON file, and then this template can be deployed via portal, CLI, PowerShell, DevOps. Like there are many tools there to deploy this ARM templates. And Bicep is something new. It is built on top of ARM templates. It just makes the ARM template more readable, more concise. And it's just, you can translate ARM template to Bicep, Bicep to ARM template. We have a playground available, as well as Bicep CLI available to do this sort of stuff. But the main point is, if an ARM template is, say, like 100 lines, right? Bicep language is will make it like 50 lines or something. So it's far more concise, but it's similar to ARM template. So that is Bicep. And then for the third one, we have Terraform, which is an open source tool by HashiCorp. And it's a very famous for provisioning and managing infrastructure. It works cross-cloud, so not just Azure, other clouds as well. And that also can be deployed via Terraform CLI, GitHub Actions, and all these things. So all of these three templates, today I'll be showing the demo. ARM template and Bicep, I'll be using Azure CLI to deploy a MySQL flexible server using Portal Cloud Shell. And Terraform also, I'll be showing the demo. So yeah, we can get started on the demo. So we have all of these three templates here in our documentation. This is a public documentation, and you can see like how to create a flexible server using Portal, CLI, Bicep, ARM template, and Terraform. So we have detailed instructions in our documentation for all of this, and I'll just be following these instructions from this documentation for this demo. So here we have the ARM template documentation to create an instance of MySQL flexible server. And we have two templates here. One is for public access, and one is for private access. In the public access ARM template, we'll be deploying MySQL flexible server with some firewall rules to allow for public access. So this is the JSON file, Azure deploy.json, that we will be using to deploy the ARM template. And then we have instructions below on how to deploy this JSON file as well, using both Azure CLI as well as Azure PowerShell. And these are the commands that we use. We'll create a resource group, and then we'll use AZ deployment group create and give that file input, Azure deploy.json as a file input to deploy it. Similarly, for Bicep, we have two templates, one to have public access. We have that file as main.bicep. And then we also have firewall rules in it defined similar to the ARM templates. As you can see, this code is much more concise than ARM templates. And so this is the main.bicep file here. And even in this page at the bottom, we have instructions on how to deploy this main.bicep file using both the CLI and Azure PowerShell as examples. You just provide, it's the same command, but you just provide the file name as main.bicep, and it will understand that it's a bicep file. For Terraform, it's a little bit different. We have instructions. We have several files in Terraform. It's just not a single file. We have a providers.tf, which lists all the required providers. Azure RM is the provider which is used to create the Azure resources. And random module is used to generate random names for the Azure resources. Then we have the main.tf, which defines all the resources that we are going to deploy. This particular example, we are going to deploy a VNet, a subnet, and a VNet injected flexible server, so a server with private access. So this is the resource that defines flexible server, and you can see all the parameters that we are passing to it, related parameters, and we are passing the subnet ID as well for VNet injection. And then this is another Terraform file that is particularly useful for creating a database in the flexible server. And all the input variables are defined in variables.tf, and the output, whatever is the output, is defined in output.tf. So we have all of this Terraform files. We put it in a folder, and then we use the Terraform CLI, here Terraform init upgrade command to initialize. And then we create an execution plan that defines like what will happen, what are the steps, what are the list of resources that will be deployed. And that is the TF plan file that will be generated when you use the CLI Terraform plan. And once you have the plan, right, you can also like look at it and make sure that it is what it is. And then you can apply that execution plan to say like, yes, please go deploy this plan and do this thing. This is the Azure portal. On that, you'll see on top the Cloud Shell. So I'm going to use a Bash Cloud Shell, which has inbuilt Azure CLI and Terraform CLI already installed. I have all the files that I showed right now in these three folders in my local file storage. So ARM, Bicep, and Terraform. We have the Azure deploy.json and parameters.json. What is parameters.json is giving the input parameters for deploying this file. You can define it per environment, like if you have like a production environment versus staging environment. This parameters.json help you define the input parameters for the sound template. So it's very useful to define parameters per region. So I'll be just copy pasting the commands from our documentation. I have already created the resource group before, so I'll just be using the AZ deployment group create command here and changing the resource group to an existing resource group. And I'll also be passing the parameters file using the parameters command. And then I'll also add a no wait. A no wait is just that let the deployment go through in the background. If you don't want, you'll be waiting until the deployment completes here. So no wait, and then the deployment will go on. You can look at the deployment later after some time in the portal to see like what happened. For Bicep, we have three files, main.bicep. I have a create firewall rules.bicep, and then a similar parameter.bicep param, similar to parameters.json. I'll be using the same command again to deploy the Bicep templates. So what you see here, these are linked templates. So main.bicep calls create firewall rules.bicep. So you can have multiple files call each other and add like a dependency. That is also possible with ARM and Bicep. So I pass the template file, parameter file, And then again, no way to say like, please deploy it in the background. I'll look at the deployment later to see whether it succeeded or not. Yeah. Yeah, this is for Bicep. And then I have all the files listed in Terraform folder as well. Main.tf, outputs, providers, variables. And once I have all of these files defined, my first step would be to initialize the upgrade. So we'll use Terraform init upgrade. And then we'll create an execution plan, main.tf plan. We'll put it out there so that you can plan the resources, like what are all the resources that will be deployed based on this. Yeah, once that is there, you will find the file main.tf plan in the folder, and then we'll just apply that main.tf plan. And here you can see that all the resources are getting started to get created, and it's using like random names to generate like names. Yeah. So yeah, this is all I wanted to show using Azure Cloud Shell. This is just one way of deploying all these three, but there are like so many ways to automate all of this. And once you have all this defined in code, right, it becomes really easy to source control and have it as infrastructure as code. Yeah.
Hey, fantastic. Thank you so much, Ram. I think we've got one more slide with some useful links.
Yeah.
For more information, go ahead. Sorry.
So yeah, for the documentation that I showed in demo, right? This is the all three documentation that I showed in the demo right now. It has very detailed steps on how to deploy using ARM template, Bicep, and Terraform. And we also have like something called quick start templates, which is defined in GitHub. It's open source. It has ARM templates to deploy like multiple things, right? A flexible server with private endpoint and a client VM and VNet, subnet, and everything. So all of this multiple resources combined together in an ARM template, and it's easily deployable. It's just one click deploy using the code there. And we also have other quick start template like to deploy with VNet integration and this stuff. So in this way, you can deploy multiple resources. You can have like all other features of MySQL flexible server, like CMK, like maintenance window. You can define all of this in the ARM templates, and it just gives you a lot of powerful capabilities. Yeah.
Fantastic. Thank you so much for sharing this information with us, Ram. And really appreciate your involvement here. And we'll let you get back to your day. Thanks again.
Thanks, Jim. Yeah.
Sure. Okay. Next, we're going to move on to the third section. We're going to have, as I mentioned earlier, the deprecation or retirement date for single servers fast approaching. And so I'd like to invite Shreya Atal to the stage here. She's a product manager too at Microsoft, and she's going to walk us through some of the options for migrating flexible server before migrating to flexible server before the retirement date, and the impact that servers still in production after that date will face. Welcome, Shreya.
Hey, thanks, Jim. I hope you can all hear me fine.
Yes. Do you want to, I know like a lot of us know you, but can you introduce yourself again for those who might not?
No, I think you did a good job. I'm Sharat. I'm a product manager in the Azure Database for MySQL team. And yeah, we know each other.
Okay. Thanks. I'll turn it over to you now, Shreya.
Perfect. So, like Jim said, Azure Database for MySQL single server is going to be retired by September 16, 2024. So it's less than a week to retirement. And folks, 85% of your colleagues have already made the successful move to flexible server. And I would strongly urge you all to do the same. Especially because since the post the sunset date on September 16th, there will be no SLAs, there will be no bug fixes, there will be no security fixes, no live support provided for you for single server instances. What will happen on post September 16th is any single server instances which have been non-responsive. By non-responsive, I mean which have failed to provide the inputs that are required for auto migration, they will be stopped. Of course, we will provide you the ability to self-start the servers after you acknowledge all the actions that are required for migrations, but it will be stopped post September 16th. And there will be no extensions provided post that date. So if you have not moved, you will be non-compliant on single server because we will be stopping support. And once we have stopped your server, we will be forcibly migrating your servers to flexible servers post September 16th in a phased manner. So you will probably, it might lead to your server being unavailable, your business continuity being hampered. So please make sure that you migrate before September 16th, or at the earliest, maybe today itself. Now, there are multiple paths to migrate from single server to flexible server. Now, the three major ones being first, MySQL import using the Azure CLI. This is a very powerful tool if you've got large workloads, especially something around the size of 1 TB. It literally upgrades to flexible server in a matter of minutes. Based on the benchmarking that we did internally, 22 minutes is the time it takes for you to migrate 1 terabyte of content from single server to flexible server. Then we've got Azure DMS. I know many of you are comfortable with Azure DMS, especially with the portal view and everything. So feel free to use that as well to migrate from single to flexible. And the last one is auto migration, which has the least overhead. And I'll tell you how you can prepare your servers to migrate to auto migration using auto migration as well. So here's what you'll need to do. I'm not going to read out all the tips, but to take a note, to take a screenshot, take a picture if required, or you can always look back at our recording later. But here is how you can make your server eligible for auto migration. And if you want your auto migration to be scheduled immediately, all you have to do is raise an Azure support ticket and let us know that you want to kickstart the auto migration. So either use one of these tools, Azure MySQL import or Azure DMS completely in your control, or use our auto migration facility by making your server ready. And then just, if you want it to be done immediately, raise an Azure support ticket and reach out to us. Good. Now, one thing that you need to keep in mind, once we are, if, for example, I mentioned the 3 steps that you need, what will happen after September 16th, right? If you have not migrated yet, we will be doing forced migrations, but not all the features will be migrated. So please make sure to make all the required changes for your security and networking features. These are the few features that will not be force migrated because they need customer input. So please take a look at our documentation. I'll share it in a bit. Make sure you configure these features right away, and then keep everything ready, or just let us know for planned auto migration. Right. That's all I had from my side. Here is the link, aka.ms MySQL SS retirement, which you can use to understand everything you need to know about the single server retirement, what you need to do, what you need to keep in mind, and what will happen if you fail to move to flexible server. That's all from my side.
Fantastic. Thank you so much, Trey. I really appreciate it.
See you.
Okay, take care. Okay, folks, last but not least, we're going to take a look at our latest feature releases and upcoming roadmap. So as Elendil mentioned earlier in the session, the flexible maintenance options are now generally available. This feature enhancement allows you to reschedule maintenance windows and even instantly initiate maintenance with the Reschedule Now option. Now let's take a look at our latest feature roadmap for Azure Database for MySQL Flexible Server. On-demand backup and export is currently in public preview. This provides an ability to export at-moment physical backup of the server to Azure storage account in Azure Blob Storage using the Azure CLI. After you've exported it, you can use the backups for data recovery, migration, for data redundancy and availability, or even for auditing and other purposes. This feature will be generally available in Q4 of calendar year 24. Long-term retention of backups is now in public preview. Previously, Azure Database for MySQL allowed for automated backups and on-demand backups to be retained up to 35 days. With long-term retention, you can now retain the backups for up to 10 years, which really assists with your auditing and compliance needs. This feature will also be generally available in calendar year 2024. Let's see here. Next, we have the MySQL Discovery and Assessment in Azure Migrate. This functionality lets you discover MySQL servers in your environment and assess them by identifying their compatibility for moving to Azure Database for MySQL. And you can receive compute and storage SKU recommendations along with their costs. This is currently in private preview, and we plan to have it go into public preview early next quarter. The accelerated logs feature went GA during the build time frame, and it provides up to 2 times the performance for your business critical servers at no additional cost. However, currently this feature can't be enabled on servers that have customer managed keys enabled, and this limitation is being lifted at the end of Q4 this year. In addition to the roadmap is the Azure Database for MySQL bindings in Azure Functions, which will be releasing in public preview early next quarter. This feature ensures native support for input bindings, output bindings, and a function trigger for Azure Database for MySQL Flexible Server. What this means is that you'll be able to read data from an Azure Database, Azure MySQL database into a function, save the data back into the database, or even trigger a function when the change is detected in a MySQL table. Next, error logs in server logs, now in public preview. This feature provides you with the option to view and download error logs under the server logs option for up to 7 days to analyze and troubleshoot issues. The plan is to have it generally available early in Q1 of next calendar year, 2025. And finally, a couple of maintenance-related features, both with the next milestone in Q1 of calendar year 2025. First, we have a virtual canary. With this new feature releasing in preview, you can opt your dev, testing, or staging servers to be in this virtual canary environment. Servers in that environment receive monthly updates in advance, providing you the opportunity to perform an additional layer of testing before, on top of our own test, before you actually implement it. And it helps you avoid any specific issues that might be in your workload. For example, like application compatibility issues. It's essentially an efficient way to manage updates, align testing and production environments, and maintain operational stability with minimal disruption. And finally, we have near zero downtime maintenance for HA-enabled servers. This feature is designed to reduce maintenance downtime for HA-enabled servers, ensuring that in most cases, maintenance downtime is limited to between 40 and 60 seconds, which is pivotal for critical businesses that can't compromise on high quality and require minimal interruption to their database operations. If you'd like to try out any of these features in private preview, please write to us at Ask Azure Database for MySQL, Ask Azure DB for MySQL at Microsoft.com. And note that we also publish a monthly update blog post that contains all of these updates, and it should come out a couple of days after the webinar, probably early next week. The latest update will be available at AKS /MySQL monthly update. Folks, that's it for today. As we close out, I'll leave you with 4 things as usual. First, check out our contributor initiative and start contributing today to get badges, official recognition, and more. We'd like you to follow us to get your gold badge, but then to help us deliver content and work on us with content for the Emerald and the Platinum badges. Next, we're going to learn more about our service. You can use these resources or feel free to reach out to us at our email ID. Third, stay tuned for more updates and announcements by following us on social media and subscribing to our YouTube channel. Our handle on YouTube and Twitter is at AzureDBMySQL. And finally, if you'd like to appear in one of our upcoming webinars or collaborate with us on any collateral, there's a form we have, a feedback form that you can use to submit ideas, let us know that you'd like to work with us. But you can also suggest other sessions, topics you'd like to have us cover in other sessions. So with that, thank you all for tuning in, and we hope you enjoyed this episode. We'll see you in our next session, which is the second Wednesday in October, 7:30 a.m. Pacific time. Thanks again. Everybody have a great day.